What's up, my friends? Today we are going to talk about ghost voltage. All right, so if you've ever been out in the field and you open up a box and you're working on something and you put your multimeter in and you're getting 120 and all of a sudden you're like 62 or 43, you're like, what is that? Why? Is there some crazy like voltage drop thing that's happening? Like what is that voltage? And that, my friends, often is ghost voltage. So there's a difference when you have voltage actually being dropped because a load's turning on, or you've got distance or something like that that's causing voltage that you would expect to be 120 to like drop to 87 or something like that. A lot of times when you kick a heavy load on, voltage will drop just until the inrush of a motor calms down and the voltage will come back up. So there's a voltage drop at the beginning of things. But typically for you to have like a drastic change in voltage and for you to be testing between things and just get a bizarre voltage, a lot of times that is a ghost voltage. It's not a true voltage. So what I mean by true voltage is something that is connected to a source that can actually push current through a load. So like power behind a voltage, right? So what I've got in front of me to kind of demonstrate this is I've got a 120 volt circuit between black and white. So it's hooked up to a breaker panel. And then I've got this bare conductor. This is not a ground. It is not grounded. It is not connected to anything over there. It's just literally sitting there staring at me in the air, not connected to anything. So we can induce a voltage on a conductor just being near other conductors that have current flowing through them. So we can either magnetically couple through electromagnetism. We can actually induce a voltage like a transformer would do in nearby conductors just because you have an expanding, collapsing magnetic field that's happening near another conductor. So you can induce a voltage on that other set of conductors, but you can also capacitively couple, and capacitance does the same thing where we can kind of induce a voltage in another conductor that's just nearby through capacitive coupling between the two. So that's what I'm going to demonstrate here. So the first one, we're going to use a normal multimeter. And normal, like testers, multimeters like this is the Fluke's 376 FC. This doesn't have a low impedance mode or a low Z mode. This actually has a high amount of impedance because as a piece of test equipment, you want a lot of impedance, so only a little bit of current has to flow through the thing for it to display values and do calculations for you. So this is a high impedance multimeter like most of the testers. The T5 600 that I have, the T6 1000, all of those are high impedance. They don't have a low Z mode to them. So let me show you just like normally how this would work. I'm going to bring my test leads over and go between black and white. And yeah, 126.1 volts. Right? Like that makes sense. I actually have 120 volts between these two. But once I go to a conductor that's not hooked up to anything and I get a voltage, this shows 52.2. Sorry, I'm looking upside down so you can see the numbers. But what is 52.2? That conductor's not actually hooked to anything. So why is there a voltage there? Well, it's a ghost voltage. If I go between neutral and bare conductor, I get 59.5. Again, ghost voltage, not real voltage. There is a difference of potential, which is why the multimeter is seeing it. There's a small shift in current, small enough that's perceivable by the multimeter, but because the impedance is so high, it can't really decipher whether or not there's any power behind that. So if I were to take and connect, like a vacuum cleaner or something between this white and this bare conductor, it wouldn't turn on. It wouldn't do anything because it's not real voltage. There's not a complete loop where current can flow and drive through a load. Same thing with the black and bare, because the bare is not connected to anything, right? So there's no true power behind a ghost voltage. But if I were to hook between the black and white, that vacuum cleaner is absolutely going to turn on. So that's the idea of ghost voltage. Now, with this meter is a Rockstar meter, by the way. This is not in any way me talking down to it. It's just not low impedance. It doesn't have a low Z mode to it. So I can't actually detect or like verify whether or not I have a ghost voltage present. For that, I have to grab a different meter. So what I have here is a Fluke 117. This is true RMS, but it also has low Z mode. All right, so in normal voltage mode, I'm just going to show you, you're going to get the same exact readings. So we've got 126 where we should have it. We're still going to detect the ghost voltage, 65.4, 57.4. So it still sees that ghost voltage, but the 117 allows you to flip this over into low Z mode, and this drops the impedance heavily. And what the meter's saying right now is, All right, voltage, let's see what you got. Can you push real current? I'm gonna put less impedance so more current can flow, and if enough flows through, I know it's a true voltage. Otherwise, it's just a ghost. It's just a fake little poltergeisty voltage. So in low Z mode, I still get a good voltage, 126, but when I go to my bare conductor, it's 0.7. It's like an imperceptible amount of voltage. There's a difference of potential that it's detecting, very, very incredibly slight. Same thing over here. So the low Z mode lets us know like, oh, this isn't like a voltage drop. You know, if I tested this and I actually got like, you know, still like 62 volts or something on low Z mode, I would be like, whoa, okay, I just have a voltage drop. There's actually real power behind this because it is driving current through this low impedance of the meter. So this might be able to actually drive a load. But when it says 0 on low Z mode, you know, oh, this is just a ghost voltage. There's something being induced on a conductor or capacitively coupled to make a voltage present. And that's not like a useless bit of information, by the way. It's really good to know that you have something being induced on something, because that might actually be a problem that you need to take care of. So this just gives you a high level of information that this meter can't give you. Now, this isn't saying like this is better than this. This one doesn't have a clamp, right? So I can't test like 200 amps worth of current. I can with this one. This thing has a 10 amp fuse, and every DMM does. So I can't test more than 10 amps of current through it. And the only way to test it is to take the circuit apart, put the multimeter in the circuit, and allow current to run through one lead through the meter and out through the other. But it can only do it up to 10 amps, or otherwise you're gonna blow a fuse, right? So there's not a single meter I've ever come across that has every single thing in it. I'm waiting. One day, I'm waiting for the everything meter. But it's just not the way that meters work. What I have here, though, is I have something that comes very close. And I love this thing. This is a brand new meter that I haven't used. And it's funny, I've had 2 electrician friends of mine. Like, one of them is a content creator that you all know, and another one was just a master electrician. And they both sent me pictures within a couple of days of each other. They're like, dude, have you used this meter yet? I'm like, no. What's so great about this little tester? And they're like, just get one. So I got it, and I'm like, okay, well, the first thing I like is, you know, very little leads. Again, having to tangle like 7 feet of leads, I don't like. But this thing, it's got a little slot. You can use it like a normal tester, right? But it's kind of like a wiggy in a weird way, or like a solenoid tester. So a lot of you guys, the old heads amongst you, like some of your older masters and journeymen, might have had these solenoid testers that are not digital. There's just a little wafer inside that has a solenoid behind it. And when you connect it to something, it sits and buzzes at you and screams at you, and it moves a little wafer inside, and it lets you know, like, whoa, okay, I actually have a voltage here. There's something dangerous. There's a real energized potential here. But when you had a ghost voltage condition, because it's making, that meter's making a solenoid, a load, if there's a ghost voltage present, it wouldn't move the wafer. So that was a really smart way for electricians to know, like, oh, I have a ghost voltage here. And this is a solenoid replacement. There's a very similar thing. It has a digital screen. It still works to detect ghost voltage, and it has 2 different parts of the meter. So if you have a certain threshold of voltage, the screen will light up. You notice there's no like power button on here for me to turn anything on. It works based off of if there's a real potential available. So this thing, boom, I know, okay, it's turning on. There's enough voltage to light up that screen to turn it on. Plus it's telling me down here, the nominal voltages, it's got up to 120 volts. It's buzzing at me. It's like vibrating in my hand. But if I have a ghost voltage, it doesn't light up. The screen's trying to illuminate, because the screen, there's certain voltage thresholds that it needs to get to be able to illuminate. But this specifically has a low Z mode as it is. So it already has a low enough impedance that it kind of drains off any current in a ghost voltage situation, where it's just going to eat that ghost voltage up. And it's going to tell you, like, okay, yeah, what you have here is a ghost voltage. You don't have an actual real voltage. This thing's also cool. Like, there's a little light on it. You know, like, I've never had a meter that just has a light on it. That's smart. We work in dark environments all the time. I don't know. I think it's cool. It's got a GFCI test mode. You can hold, right? So I can get a real reading here, hit the little hold button, take it off, and my reading stays. It's got resistance too, so I can hit that. And it can even do motor rotation if you're working with motors. So like across the board, this thing's just a really killer meter, but I love the fact that I could have a meter that's inexpensive, that fits in my back pocket, that's a tester, that it does all of these things, and it's really convenient to use. And that's the reason that I've used the T5 and the T6 from Fluke for so long. Like you guys, for the last 10 years, 11 years now, you guys have probably seen me with that thing carrying in my back pocket on job sites. That's the meter that I love. This thing is now in my back pocket because I'm really loving it, and I'm trying to get familiar with it enough and just kind of, you know, break it in and see what I like about it. So far, I'm really, really happy with this thing. So that's all I got. That is Ghost Voltage. That's this new Fluke T Plus Pro multimeter that I think you guys should at least give a shot. Test it out. Let me know what you think. But yeah, love you crazy people. I'll see you in the next one.